All right, this video we're going to prove a lot of the derivative rules that we talked about. I'm not going to prove all of them, for example, the trigonometric and the logarithmics and exponentials. Those because you can kind of do those fairly straightforward on your own, or if you get stuck, you can ask me. Some of those are easier to prove using some of the other rules like quotient rule, stuff like that. But I'm going to prove kind of the other rules here, and if you get stuck or want to ask about any of them, feel free to. You can also check the timestamps if you want to jump ahead to a specific rule. These are also, you'll find plenty of proofs or derivations elsewhere if you want to look those up as well. All right, so the constant rule is pretty straightforward in that we just use the limit definition. So the limit as delta x approaches 0 of the function, which the function is c, minus c over delta x, because f of x plus delta x is going to have a result of c. F of x is going to have a result of c because it's a constant, it doesn't change, over delta x, and this means that we get the limit as delta x approaches 0 of 0 over delta x, which is just equal to 0, and that's what we said our constant rule was. So nice and straightforward. For the power rule, that one has a few more steps involved, and I'll have to check my notes for some of these just to make sure I write things out. We're still going to use the limit definition, so limit as delta x approaches 0. And for a power rule, that's going to look like x plus delta x, and the function was x to the n, so I'll write that up here just so we can reference it. X to the n minus x to the n over delta x. Now what we're going to do here is we're going to use a binomial expansion for x plus delta x to the n. If you don't really remember this, it probably came up if you know Pascal's triangle. You probably looked at it at some point, but for sake of this, just you can kind of take my word for it. But we know that x plus delta x to the n power, that's going to expand to x to the n plus n times x to the n minus 1 times delta x plus n choose 2. This is a combinatorics thing. It comes from Pascal's triangle too, if you wish. N minus 2 times delta x squared plus n choose 3. These will give you some number that's our coefficient, by the way, if you're wondering what they are. N minus 3 times delta x to the third. And you'll see that I'm just expanding this out. That will continue until our last few terms will have, what are they? N times x times delta x to the n minus 1. And finally, the last term, of course, will be delta x to the n. So, this is a standard binomial distribution. So now, if I change this slightly by just subtracting x to the n, right? Because we're basically going to take what I've got on the right side here and transform it to an equivalent function to what I have over here. So x plus delta x to the n minus x to the n. Well, if I subtract x to the n on the right, it's just going to cancel that first term. So I'm going to get n x to the n minus 1 delta x plus n choose 2 x to the n minus 2 delta x squared plus et cetera, all the way to the end of delta x to the n. Now if I do the same thing and I'm going to divide both sides by delta x, well, on the left I'm going to leave that, but on the right I'm going to cancel this delta x from all of our terms. So I'm going to get n to the x to the n minus 1 plus n choose 2 of n to, or x to the n minus 2 times delta x plus a bunch of terms, and at the end I'll have delta x to the n minus 1. Now you'll notice all of these terms at the end have a delta x in them. So we start with delta x, 1 power of delta x. When I cancel the delta x from this third order term, it'll get delta x squared. When I cancel delta x from this second to last term, it'll be delta x to the n minus 2. And of course, when I cancel delta x to the last term, that's where I get my delta x to the n minus 1. So all of these have a delta x in them, which will become, some of you might be seeing why that's relevant, but it'll become relevant here in our next step. So then the last thing I need to do to get this left side to look like my original expression is to take the limit as delta x approaches 0 of x plus delta x to the n minus x to the n over delta x is equal to the limit as delta x approaches 0 of all of this stuff, which when I do delta x to 0, that's going to drop out all these terms towards the end, and I'm going to get just n to the x to the n minus 1. And you'll notice that is the result of our power rule. So this is the derivative of x to the n by definition. And then I expanded and reworked all of this to get an equivalent expression on the right, which we've shown just now is n times x to the n minus 1, which is our power rule. All right, sum and difference rule. This one's nice and straightforward if you use your limit definition. So limit as delta x approaches 0. And remember, our function here is h of x is equal to f of x plus or minus g of x. So this is going to be f of x plus delta x plus minus g of x plus delta x. So that's from that first bit. Then I'm going to subtract f of x plus minus g of x all over delta x. Then I'm going to just do some rearranging here. So I'm going to get limit as delta x approaches 0 of f of x plus delta x minus f of x plus minus g of x plus delta x. Now I'm going to write this negative when it gets multiplied by the plus minus. I know that that's actually going to flip the sign on this. So I'm going to rewrite it as minus plus. I'm not sure how standard this convention is, but I have seen it used, and that just indicates that these are opposites of each other. All over delta x. That's going to be the limit as delta x approaches 0 of, now this first, I'm going to separate these out. F of x plus delta x minus f of x over delta x plus minus g of x plus delta x. Now, because this is plus minus, and I know that these have to be opposite signs, this right now is kind of taking on a positive value. So that means I have to have the minus g of x here. If you want to prove it or show yourself more rigorously, you'd have plus minus, and you'd have plus minus a negative g of x. That way, when you did the plus minus here, you preserve that negative g of x. And if you look at this all together, you'll notice this first term is the derivative of f of x. The second term is the derivative of g of x. So we have the, that shouldn't be a limit. It should just be f prime of x plus or minus g prime of x. And that's what we saw before on the sum and difference rule. All right, the product rule. This one has a bit to write out with it. Did I skip one? I guess not. Okay, so for the product rule, this one has a bit more to write out, but we can just track along. Limit as delta x approaches 0 of f of x plus delta x times g of x plus delta x minus f of x g of x over delta x. Now, for reasons that will be clear in a minute, I'm going to add and subtract a term from the numerator. So f of x plus delta x, g of x plus delta x, that's exactly the same, still over delta x. Now I'm going to add and subtract, and I'll write this in brackets here just so it's a little bit easier to see. So I'm going to subtract minus f of x, g of x plus delta x. So I subtracted this, so I need to add another so I don't change the overall expression. So plus f of x, g of x plus delta x. It's a little sloppy, let me rewrite that. And switch back to my pen. G of x plus delta x. So you see in brackets here, this is equal to 0, so I can just add 0 arbitrarily if I want. And then minus f of x, g of x, all over delta x. Now I'm going to group these two together and these two together as separate fractions. And I need the limit as delta x approaches 0 here. So I'm going to limit as delta x approaches 0 of, like I said, that first group. So f of x plus delta x times g of x plus delta x minus f of x times g of x plus delta x all over delta x. And then plus, like I said, I'm going to do those last two together. So that's f of x, g of x plus delta x minus f of x, g of x. Now, if you followed the proofs we've done before, and if you kind of are looking at this, you might see where we're going with it. But on this first one, I'm going to factor out g of x plus delta x. And on the second, I'll factor out f of x. So this is f of x plus delta x minus f of x over delta x times g of x plus delta x plus f of x times g of x plus delta x minus g of x over delta x. Now you'll notice, or if you remember back from our limit rules, I can apply the limit to different, to the parts of these terms separately. So I'm going to apply the limit to the g of x plus delta x. I'm not going to apply it to this f of x portion just yet. When I plug in delta x approaching 0, I get g of x times the limit as, oops, let me just undo that. So I'm going to write that a little bit neater. Limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x plus f of x times the limit. Similarly here, I'll apply the limit to f of x, but because there's no delta x in it, I get the same thing. As delta x approaches 0 of g of x plus delta x minus g of x over delta x. And we'll notice this right here is the derivative of f of x. Similarly, we have the derivative of g of x in our second term, so I get g of x times f prime of x plus f of x times g prime of x. And I don't remember exactly what we had written on our notes, but this is an equivalent form of the derivative of, of whatever we wrote as our product rule. So that's a proof of the product rule right there. And lastly here we have the quotient rule, and this is going to be similar to what we've been doing before of writing out our functions using the limit definition and then doing some clever algebra. So limit as f of x plus f of x over g of x plus the delta x terms minus f of x over g of x over delta x. Now what I'm going to do here is multiply this whole expression by g of x plus delta x times g of x, and if I'm going to multiply, I also need to divide, or think about it alternatively as I'm multiplying by this fraction that equals to 1. So this will give me limit as delta x approaches 0, and I'm going to distribute that through the numerator. So I'm going to get f of x plus delta x times g of x, because the g x plus delta x cancels there. In my second term, I'm going to get f of x times g of x plus delta x, because the g of x is canceled. And in the denominator, I'm left with my g of x plus delta x times g of x times delta x. Just checking my notes to make sure I've got this properly. Yep. And then I'm going to, like we did with the product rule, I'm going to add and subtract the same thing, which is effectively adding 0. So I'm going to do plus f of x g of x minus f of x g of x. So that's equal to 0, which means I haven't changed my expression at all. That gives us limit as delta x approaches 0 of f of x plus delta x times g of x minus, I'm going to use the second one, I'm going to bring the second one forward, so minus f of x g of x. All of that still over g of x plus delta x times g of x times delta x, plus the limit as delta x approaches 0 of negative f of x g of x plus delta x plus f of x g of x all over g of x plus delta x times g of x times delta x. Okay, so I just split this into 2 bits. Now what I'm going to do is I'm going to factor out all this g of x stuff. I'm going to apply the limit to this denominator g of x, because again, with multiplication division, we can apply the denominator, or we can apply the limit separately. And that will give me out front 1 over g of x squared, right? So the limit as delta x approaches 0 is just going to give me g of x, and g of x, like so. So limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x, and I'm going to factor out the g of x from the numerator in this expression. So I have this like so. Now I don't like this negative here for reasons that maybe are apparent, but will be apparent in a second if they're not. So I'm going to factor out a negative, which means I need to factor out -1 from the whole numerator. So that's going to give me negative limit as delta x approaches 0. Now because I factored out the g of x already in the front here, that's going to give me f of x times g of x plus delta x If I factored out a -1, I need to multiply this by -1, so minus f of x g of x all over delta x. And in this case, I'll also factor out an f of x from this expression. Leave that at the end, and then close my parentheses. And actually, that f of x we'll technically still have in our limit. Okay, if we look at this first expression limit as delta x approaches 0, we have the derivative of f of x times g of x. G of x doesn't change as the limit goes to 0. Then I have minus the limit of the derivative of g of x. The f of x doesn't change as the limit goes to 0. So I have 1 over g of x quantities squared times f prime of x g of x minus g prime of x f of x. And if I write that like we wrote it before, it's going to look something like this. I don't remember what I had written for you before, but it's going to be something like this, which is proof of our quotient rule. So there is kind of what we've worked through, all the basics. The rest of the rules are either very similar, or I've shown them actually as an example, or they use something other than the limit definition. So I'll do those separately, or if you have questions, let me know.